So hello, everyone, and welcome to today's webinar on active learning, or in other words, how to save time and money on data annotation. So I'm Olga Petrova. I'm a machine learning engineer here at Scaleway, and I'm very happy to co-host this webinar today with Kairntech, whom I will present shortly. But to start with, I just wanted to give you an outline of the structure of the webinar so that you kind of know what to expect. So we will start with some quick introductions, who are Scaleway and Kairntech. Then we'll move on to the technical part. We'll discuss what is the interest and the challenges of data annotation in natural language processing. Then we'll move on to the main subject of the webinar, which is active learning. Most I will present the theory and also some of the things that might pose additional challenges in practice. And then Kairntech is going to demo their platform and discuss how they solve those practical challenges in their product. And then finally, as Melody said, the Q&A part will come at the end. So please feel free to post your questions at any time. So Scaleway is a European cloud provider with about a 20-year history of working in the infrastructure domain. Scaleway originates from France, but actually we now have data centers in 3 European countries, in France, Netherlands, and now also in Poland. Under the Scaleway brand, there are 3 distinct ecosystems that serve all sorts of cloud and infrastructure needs, including Scaleway Data Center for private infrastructures, Scaleway Elements, the public cloud ecosystem, and Scaleway DediBox, the high-end dedicated servers. Our clients come from over 160 countries at this point. And just to give you some idea of our size, I put some stats. We are the number 1 in private data centers in France, number 2 in public cloud in France and Europe, and top 5 infrastructure as a service providers in Europe, and also in top 10 worldwide. And now I would like to give the floor to my colleague from Kairntech, Vincent.
So hello everybody. So thank you, Olga, and welcome all. So my name is Vincent Nibart. I'm a Chief Product Officer and co-founder of Kairntech. So Kairntech is a software company specialized in NLP, natural language processing. What do? We develop and sell a platform to make NLP easy to use, not only for data scientists, but also by domain experts without any IT skills. So our goal is to address the end-to-end workflow from dataset creation, which is the topic today, to the deployment and monitoring of AI models in production. So today, my mission is to run a demo of our platform and present to you in details a first implementation we've done of an active learning loop to speed up dataset creation. So, Olga.
Yep, thank you, Vincent. Okay, so the technical part. So first, I'd like to start with a few words about data annotation in general. So I assume that those who are present at today's webinar have some interest in machine learning and data science. And as such, you are probably aware of the fact that data can be kind of roughly divided into 2 categories, meaning structured and unstructured. So structured data is basically all kinds of data that can be put into a table form. So if you have, certain observations that can have multiple properties, and for each observation you have a value for a property, and you can put that in a table, we call that structured data. Unstructured data is something that we as humans are more used to. So this would include, images, videos, text, audio, those kinds of things. And of course, unstructured text is all around us. So the question then is how can we employ machine learning, or the recent advances in machine learning, especially in order to make use of this text? So to do processing or to generate some text from scratch, etc. So in general, I would say that NLP, or natural language processing, in the beginning, it was kind of lagging behind computer vision when it came to the speed at which advances were being made in deep learning. So deep learning is the branch of machine learning that deals with artificial neural networks. However, recently that has kind of changed for the benefit of NLP. And by recently, I mean about 3 years ago, when the transformer architecture came out. This was the kind of ImageNet moment for NLP, where ImageNet is the huge annotated dataset with millions of images that has really kicked off the progress of deep learning for computer vision. So Transformer showed up in 2017. Since then, there has been plenty of related work done for natural language processing. And when it comes to kind of practical applications that individuals or companies are doing, a lot of the time we employ something called transfer learning. So transfer learning is when you have a model that has been trained on some supposedly very large data set, and then you can use all or a part of that model for fine-tuning your model for your own purposes. This is something that you typically do on a smaller data set that you have available. Now, for NLP, this is often done on models that have been originally trained for language modeling. And language modeling is basically a text generation task that can be trained in an unsupervised or more technically correct, I guess we would say, self-supervised manner, where we just consider some huge corpus of text, say all of Wikipedia, and we train the model to generate, say, the next word in the sentence or a missing word in a sentence. So this was actually the way in which, for instance, BERT was trained. BERT are the transformer-based kind of encoder. This is a model that gives you contextualized embeddings for words that you may have heard of. So the thing is that even with all of these pre-trained models that are actually publicly available a lot of the time, it is important to understand that you still need to fine-tune them for your task at hand. And for this, often you actually still need a lot of data. So just to give you an example of the amount of data that might be needed, although this, of course, depends on your use case, you can achieve state-of-the-art performance on the question answering task with BERT. However, to achieve this performance, you actually fine-tune the model on the so-called SQuAD dataset, Stanford question answering dataset, that has over 100,000 question answer pairs that have been annotated manually. So hopefully here I managed to convince you that you still need a lot of annotated labeled data for your NLP projects. And now I'd like to discuss some of the challenges that exist in data annotation in NLP specifically. Well, first of all, most practical applications do come from supervised machine learning because, of course, GPT-2, GPT-3, they're incredibly fun models to play with. But in the end, most of the time, we don't actually generate new text from scratch. Most of the time, we need something more mundane that we need labeled data to train. Now, here's where NLP is different from computer vision. In particular, in NLP, we have to understand the text that we are annotating. So this creates a language barrier for the human annotators that doesn't necessarily exist in computer vision. And this makes it harder to, in particular, outsource your data annotation. And this is something that is very frequently done for when you have really a lot of data to annotate and you want to consider the costs of the process involved. And of course, there's a huge imbalance in the availability of data for different languages. So many of these pre-trained models come pre-trained, for instance, in English or in one of the, let's say, more common languages in the world, but not necessarily in one of the more rare ones. So that creates additional challenges for the NLP domain. So all of these things considered, the question is, how can we get away with as few manually labeled training samples as possible without compromising the final performance of our model? And this is the problem that can be solved with something that is called active machine learning. So active machine learning is also known as human-in-the-loop machine learning because it involves the model kind of interacting with the human during the process of training. And the let's say central idea behind active learning is the fact that not all data is going to be equally useful for your problem at hand. Sorry. So in general, for your model training, you want the label data to be, well, you want it to be nice and clean and everything, but you want two things. You want it to be representative in the sense that you don't want to have, say, noise or outliers, the kinds of training samples that don't really represent the kind of data that you would be seeing in the wild when you have your trained model and you want to make predictions. At the same time, you also want it to be diverse. You want to kind of cover a good range of the data distribution that you would expect your model to work for. So active machine learning is basically an approach that can be applied to kind of handpick the training samples out of the sea of unlabeled data points that you have, that is going to work out for the benefit of the final performance of the model. So to explain what I mean here in more detail, let's move on to the slide. So in active learning, you would be iteratively training the model, and you're going to let the model actively, this is where the name active learning comes from, query you for the labels of data points that it finds most useful. So what I'm going to discuss today is the so-called pool-based active learning, as opposed to stream-based active learning. So we won't go into that, but if you have questions, feel free to ask. So the way that pool-based active learning roughly works is the following. First, you want to label some data, because of course, if you have zero labeled data to begin with, you won't really get very far. So you label some data and you add it to your labeled data set that I will denote as L. Then you're going to train the model on L. If your model has been pre-trained before, you're going to fine-tune it. You can also train it from scratch, so it depends. And after that, you're going to get predictions of the model on your unlabeled data. So that's what I refer to as U. So typically, of course, unlabeled data is much cheaper to obtain than labeled data because there is no cost of annotation. So then you run inference of your trained model on all of your unlabeled data or some part of it. And then you're going to employ something called a query strategy in order to choose which data in this U dataset you want to label next or to prioritize for labeling. And then once you do that, you label this data, you add it to your labeled data set, train the model, and you just repeat. And this is the active learning loop that Vincent mentioned, that I think you'll talk more about in the demo. And basically, you just proceed up until you either, well, one of two things happen. You either run out of your labeling budget or you reach the final performance that you're happy with. Now, what's interesting here is this query strategy, because, of course, there are many ways to select which samples to annotate. Something that is kind of very common. So if there was a textbook on active learning, I would say that this was a textbook example of a query strategy. This is called uncertainty sampling. Here, you base decisions on the probability of something being assigned to a particular class, for instance, or in other words, on the confidence score that your model assigns to its prediction. And again, there are actually multiple variations of uncertainty sampling. There's least confidence, margin sampling, or it can be entropy-based, etc. So the one I will mention is called least confidence. And here I have just included the active learning loop that I discussed in the previous slide on the right. So this is how it works. You labeled some data, you train the model on the labeled data, and then you want to get predictions of the model on unlabeled data. And since you have the confidence scores, what you do in the least confidence query strategy is that you're going to actually prioritize the unlabeled samples that you got the lowest confidence score for. The idea here is that if you get high confidence scores, that means that your model has already kind of learned certain features, and those training samples wouldn't be as useful to the further training of the model. And in fact, in practice, since you have certain training samples that have obtained this high confidence score, you can even automatically label them, or have the human validate them and then label them, and add them to the label dataset. So this is actually very similar to a semi-supervised machine learning approach that is called self-training. So you can also combine the two. Now, in this least confidence approach, it works great in theory, because in theory you keep on prioritizing the training samples that you didn't really learn yet, and as you prioritize them, you learn them. So you make the most out of your labeling budget. However, in practice, it doesn't quite work that way. So since in the least confidence query strategy, you're always selecting training samples with the least confidence, actually, everything that is noise, everything that is an outlier is going to be the first line to get selected. And since in practice, most of our data sets do contain those kinds of problematic training samples, you don't necessarily want to go with that one. So I will let Kairntech talk shortly about how they overcome this issue. Also, in theory, like if, say, you go on the archive and you read a preprint on active learning, you will see that typically you start training your model in this active learning loop, and then the final performance that you get is again coming from the same model. What I mean here is that you're not using, one model for the active learning loop, and then you're, say, using a different, more powerful, or an ensemble of models for the final test of the performance. So this is something that, of course, makes it easy to compare different approaches, because it's a nice and clean way. You only have one model, and the idea is to get the most out of that model. However, in practice, you might have to consider the resources that you have for training, because here inside the active learning loop, you have to actually train the model each time, which of course is more resource intensive than, say, just running inference. And I think this is the part, right, where I give the floor back to Vincent to talk about how they implement active learning in their platform.
Okay, thank you, Olga. So before running the demo to see how in practice we can do active learning, I would like to share this drawing, very simple, to give you as an introduction of what I'm going to show you. So it's exactly the way we have implemented this loop. As a first stage, the first goal, the goal is to train a model on labeled training data, and in our implementation in the platform, we use different algorithms depending on the NLP task. So what I'm going to show you is using the CRF suite to train the model, and this type of algorithm is able to provide us a confidence score that we will use then later on. The second stage is the query, as Olga mentioned. So it's how to select example in the pool of documents we have in the system from unlabeled data. And here, what we do, it's a combination of uncertainty sampling methods with a diversity-based selection, meaning that we don't want to have something boring for the user. So we have to be very cautious on a smart query in the document pool. Then, when we have a selected example, we expose this example to the domain expert, to the annotators. And here, what we propose in our solution is to perform some auto-labeling. So the goal of that is to save time to the annotators, even if it might be dangerous in some way. And of course, we proposed some annotation features with the ability to validate, to reject, or to skip some suggestion we can propose to the user. Finally, the goal, of course, is to add a new labeled data. in the training data set. And here we have also the ability to add a counter example. So that's very important because the model can learn on label data, but also on counter example. And then as soon as we have new label data, then automatically we can iterate and repeat this loop in the platform behind the scene, of course. So that's it now. So I think now we can jump to the demo. So I'm going to share my screen. So here we go. So I hope that everyone see my screen. So that's our platform. This is a SaaS platform running on Scaleway cloud. And this is a multi-user application. So I'm going to log in now. And here what you see is that it's my homepage with 3 projects. I am able to create a new project on my own, of course. And here we will focus mostly on these 2 projects, focus on news analysis. So the first one, news analysis, is the final project that I will show at the very end of the demo. But most importantly, this one. So you see that in this project, I have already uploaded a set of documents, more than 500. You see that because it's a news article, we have segmented all the content in different segments, and I've got no annotation. So this project is a sequence labeling project. So don't get me wrong, it's a very simple task that I want to demonstrate for the sake of simplicity, because the goal is really to explain you in details how we can implement an active learning loop. Okay, so let's go to this project. So, and let's select one first article. So you see that it's a purely news article. I can browse from one document to the others. Okay, and you see on the right panel that I can leverage the native metadata of the document as well, which could be which are important as well, as you will see later on. So imagine that I am a journalist and I want to build my own system, my own model to extract automatically some key information in my text. So we will consider a very basic example. So let's say that I want to build a model so as to extract automatically 3 key concepts, entities. So like people, location, and organization. So you see here that I can define as many labels as I want, just simply doing that. Then I come back to the document view, and I can activate my pen here, and I have access to the 3 just created labels. So here, as you have understood, here I have no label data at all. So the first challenge for me is to start annotating my content so as to be able to trigger automatically an active learning loop, because for active learning loop, I need label data. So how can I do? First, I can browse my document as I do here, and I can say, okay, in this document, I've got one guy here, Sean Connery here. So you see that I can very easily start annotating, labeling my document. But I can go faster. That's because otherwise I have to read each and every article, so it could be very time consuming. How can I save time? So I can go to the Explore view, where we expose here not the document, but the segment. So basically by default is a sentence here. And since we have embedded in a search engine in the platform, then I can leverage this search engine and trying to look for all segments, including deputy, because with deputy, I guess that I might find some people name. So here is the case. So I can annotate new 2 names, for instance, and then same thing. I can ministry, for instance, and then again I can have a list of minister, so better minister. I can have a list of people named like Gérald Darmanin here, like Taouf Sharfeddin, Mohamed Boutzeta, and so on. And what do I see here on the top right? I see that a job has been initiated. And here it's the beginning of the active learning loop. So the system has seen that I've already made a few labels in my in my content, and then the system train a model, a first model, and then I will this model will be the system will query the document pool so as to propose some examples that will be proposed to the user. So you see here the blue box saying that, hey, look, now I've got some suggestions. So I can click on this panel, and here I arrived on this panel here. So what do I have exactly here? I've got a list. So it's not very the first one at the very beginning. What is it? It's a list of a sentence where we have a confidence score. So unfortunately, it's a strength because it's a bit high here. But anyway, the goal is to expose the segment where there is an uncertainty, and we have to help the system to say if it's correct or not correct suggestions. So what you see here as well is that in dotted line, this is the proposition. This is the auto-labeling features that the system do on the content. So for instance, here, as a user, I have to help the system understand that Latin America is not at all a person name. So I will reject this proposition, and then I will validate the segment. And so by this way, I will add this new label in my data set. So very quickly, because the first one are really
Vincent,
not really relevant. Yeah.
Sorry, I just wanted to, sorry for jumping in. I just wanted to say that I think if you plan on going for a second iteration of the active learning loop, I think it will be interesting to see how the model, learns better, because right now, of course, it picked out quite a few things that are not people as a person. Something that I wanted to ask you to maybe elaborate a little bit on is, the confidence scores that are provided here as percentages. Because here you're clearly not using least confidence, because these are actually quite high confidences that are posted. So I just wanted to ask, why this was, and kind of what is your objective for prioritizing the data.
So here the model provides a confidence score, and the goal is to sort all these segments from the lower score to the higher score. So the goal is to force the user to say if it's correct or not correct. Okay. So the score is provided by the model, of course, and the uncertainty sampling is done mostly on the kind of intermediate stage. So it's not the least, it's not the highest, but it's intermediate stage.
Mm-hmm.
Okay,
I think
so here,
this is how it seems to mostly be done in practice when uncertainty sampling is used on a real data set. Because, of course, as I said, with least confidence, you're very likely to pick out things that will be just nonsensical, which wouldn't really save you time on data annotation. It would actually kind of do the opposite. You would be rejecting lots of the suggestions that are being made. Mm-hmm.
Exactly. So here in this segment, you see that the system proposed me nevertheless Trump. So it was not correct, but I correct with the Trump, and then I validate this segment. Okay. So you see that while, so I can maybe reject this one, and I can accept this one because it's good, and I have to check if in this sentence I don't have any more a person. And here I can correct and say, okay, it's Sandrine Dia-Amon, and so on and so on. So here, what we see is that in real time, behind the scene, the model is updating. So I can refresh my list of suggestions, And you see that here I've got a new list with the lowest score. So again, we are around 30, 40, 60, 70 sometimes. At the very beginning, it was pretty high, but you understand here the goal is really to propose where the system has adopt a lot, and we have to help him. So here again, I keep on working, and I say, okay, Anthony Van Dijk, it's a people name. Maybe McEvoy, I don't know, so I go pretty quickly. So most interesting, most importantly here, sometimes you need the context, because here I'm just exposing the segment. So in case you need the context, I can activate this button here to help me taking a position on this candidate. So that's very interesting. So I said that I can say that here just Amanda Elliott is the person name, and I can validate only this segment in this document. So Luciana Berger, I think it's a people person, maybe Corbin, but okay, let's do it. But and sometimes what we see is we might need to have the full document to be able to say if it's a correct suggestion or not. So I can switch to the full document view, and here it's not very good here, so I can correct and go to the next one and so on. So you get the point. Here, okay, it's not, I've got to double click here, but anyway. And here you see that the system is focused on this segment. And again, it's I have to correct it. Okay, so you get the point. I've got access to the content of my document, especially when it's a long document. It's very, very important. And again, I can update. I can go back to my segment view, and then I can see that more and more I will have some good candidates in my suggestion. So I understand that progressively my model is converging and able to extract automatically some people name. So I won't do, of course, the whole job during this demo. And here I see that in just a few minutes, I've already almost 40 annotation on my dataset. And I can, of course, go back in this view and use my search engine and to spot all the segments. So I've got 14 segments, but much more annotation, of course, on this training data set. So with all this tool, with the search engine combined with the facet, I have everything to have something high quality, because the training data set is really the key things to build when it comes to create a model. So what about the model now? Because the goal is not to create only a data set. The goal is to create a final model that I would like to put in production in my workflow, on my news article stream and so on. So when it comes to the final model, what we propose in the platform, it's this experiment view, where you can create different experiments on this data set. And here we give the ability to select different framework that we have selected as some open source component. And here, for instance, I can say, okay, I want to add a new experiment based on SPACY, which is an implementation of neural network that you may know. And here we expose all the different parameters on this framework. So of course you can, if you don't have any data science skills, you can skip and automatically save a new experiment. But if you're more familiar with this framework, you can activate the advanced parameters and then say, okay, I know SPACY and I would like to have more 50 iteration because I know that I will have a better results. Okay, so you can prepare a set of experiments with different frameworks and finally launch all that experiment to see. So you see here that in the cloud, automatically we train the system and we will evaluate the quality of all this experimentation for you, so as to be able to make a very quick comparison of all this algorithm. So we won't maybe we won't wait for all the experiment, especially FLAIR, because FLAIR it's a more quite a big, it's a neural network algorithm where you can add embeddings and so on. So for this type of experiment, it's very useful to have GPU resources in the cloud and so on. But it appears that once the experimentation is done, you cannot. So it's very poor here because the data set is poor. But of course, but you can then see the global quality of the experiment. Okay, so now just to wrap up this demo, because it was just an experiment here, I would like to show you the final the final data set and the final model. So of course, in terms of labels, we can have much more labels in the project. If I go to the Explore view here, you can select and filter on all the people that are part of your label data set. And finally, if I go here and I select this text, so sorry, I can show you that here in that case, I've got 3 experiments with among them the FLAIR experiment with 83% of quality of F measure. So now, if you want to test this model on this new content, you just have to select this model as a final model and to see on this article how we can effectively tag the content automatically. So I guess it might take a little bit time, but it should happen. Yeah, right. That. So you see here that we are able to build very efficient model, able to analyze automatically some content. So of course it's very standard. It's sequence labeling on news with very standard entities, but we do similar job on other type of document with other domain, of course, and that's all. This platform is all about this stuff. So I think I'm done with the demo now. So I hope it was interesting for you all. And now I think we can move to a question and answer session. And before that, you see on my screen the contact from Scaleway and Kairntech if you want to learn more, of course, and if you want to contact us.